Hello, today we're going to talk about errors in sampling and we're also going to talk about sampling methods. So let's first talk about the errors in sampling. So the terms below should already be familiar to you, being that they are frequently used in statistics. So take a moment to read through those and pause the video if need be. So the most accurate way to investigate a population of interest is to use what we call a census. Because a census is a collection of information from the whole population, most of the time it's impractical to obtain data from an entire population. And it will be easier for us to conduct a survey of a well-chosen sample or group or subgroup of a population. When collecting data to estimate a particular characteristic of a population, the estimate will most likely be different from the actual characteristic. This difference is what we call the error. So there are four main types of error. So the first type of error that we have is what we call a sampling error. This happens when a characteristic of a sample differs from that of the entire population. This error is random and will happen even when the samples are chosen specifically to avoid bias. So these samples these errors cannot be avoided. The next type of error that we have is the measurement error. So this describes inaccuracies in the measurement at the data collecting stage. It usually has to do with rounding. So for instance, you may round something to the nearest centimeter and you may end up wanting to give all your measurements in terms of the nearest centimeter, but then somebody may give an answer in terms of the nearest inch, or they may round to the nearest tenth for everything, but then some numbers may be rounded to the nearest hundred. The next type of error that we have is what we call a coverage error. And this happens whenever a sample does not truly reflect or represent the entire population that we are trying to find information about. So to avoid this error, samples should be large and unbiased. The next type of error that we have is what we call a non-responsive error. This happens whenever a large number of people chosen to take a survey do not respond to it. And they may not respond to it because they may feel like it does not include them or it is not for them. So, for instance, anytime you have a customer satisfaction survey, people may not fill the survey out if they feel like they had a good experience because a lot of people only want to report things whenever it's negative. So now let's talk about sampling methods. So the best way to avoid bias when choosing a sample is to make sure that the sample is randomly chosen. So there are 5 types of sampling methods that can be used. The first method is the simple random sampling. Each member or set of members of the population has the same probability of being selected. Methods of random sampling are drawing names from a hat or by using a random number generator. The next one is going to be called systematic sampling. So a sample is going to be created by choosing members of the population at regular intervals, meaning that every nth person will end up being selected to take their survey or to respond to a certain number of questions. Convenience sampling. When people are chosen to take part in a survey because of convenience, or they are more likely to respond to the survey. So basically, whichever is easiest to get, you're trying to get the data easily. So next we have stratified and quota sampling. So members of a sample are chosen from a population with many subgroups. that should be represented. Okay, so anytime you have a population with subgroups, you want the information or the data for that subgroup to be represented what we call fairly. And we should know that if members of each subgroup can be chosen randomly to minimize bias, this is what we call stratified sampling. And if members of each subgroup are specifically selected, this is what we call quota sampling. So quota sampling is when you are likely to have more bias, and stratified sampling is when you are able to have or you want to have less bias. So now let's look at some examples. Example 1, it says the school district wants to find out whether families prefer going to a school in their neighborhood or like having the option to attend any school anywhere in the district. They decide to sample 25% of the families using systematic sampling. Show how this sampling would be selected. So you have to understand that because they said they want to survey 25% of this population, or the 25% of the families, that is equal to 25 over 100, or you can say it's equal to 1/4. So what this is saying is that every fourth customer is going to be surveyed or sampled, okay? So here I can say every fourth in family here will be surveyed. So what we have to do is we have to understand, or we have to find out, okay, what number family is going to be the starting family. So what we want to do here is we want to pick a random number between 1 and 4. And then from there, we're going to increase by 4. So if I use my random number generator, if I press math and I go over to probability, and then I go to my random integer. The reason why I'm saying an integer is because we're talking about families and I can't have a decimal. I know that the lower bound is going to be 1 because that's the least amount of families I want to deal with. And then the upper is going to be 4 because it says 1 in every 4 families. And I only want to pick one number at a time, so that n is going to be 1. Once I paste that in and hit enter, it's telling me that I'm going to start off with the 4th family. So basically, the district, I can say here, the district will start with the 4th family, then survey the 8th family, the 12th family, the 16th family, the 20th family, and so on. Okay? So that's how that will work. So, example number 2, it says West Charlotte has 491, 452, 386, and 347 freshmen, sophomores, juniors, and seniors, respectively. A sample of 200 students is needed. How many should be randomly selected from each year? So the first thing that we want to do here is we want to figure out the total number of students. So if we have 491 plus 452 plus 386 plus 347, that is a total of 1,676 students. So what's going to happen there is we have to figure out the fraction. So what we're going to do is we're going to figure out what percentage or how many or what fraction should be represented by each year. So I'm going to look at the freshmen. So if I look at the freshmen, I will take 491 and divide it by 1676, and that will give me the percentage or the fraction of my students that I should be focusing on that should be freshmen. And then I'm going to take that number and I'm going to multiply it by how many people I actually need. And I need 200 people. So when I multiply that by 200, I end up getting approximately 59 students. If I need sophomores, I'm going to take 452 out of 1676 and multiply by 200, and that's going to give me approximately 54 students that I need from the sophomores. Juniors, I will have 386 of them out of 1676 times 200, and that is going to give me approximately 46 students from that class. And then last but not least, seniors, we have 347 over 1676 times 200, and that is going to be approximately 41 students there that I will need as far as freshmen, juniors, and seniors. So this is how many people I will need from each class or from each grade level. And you know that you are right because if you add up all these numbers, 59 plus 54 plus 46 plus 41, we get 200, right? So if you have any questions on errors in sampling or sampling methods, please ask me and have a great day.